Hello everyone, welcome to Sunday. And in this video, we're going to see how to implement a simple multimodal RAG Q&A system. Okay, and we'll be implementing this in a simple Colab notebook, and we are using our Cohere embedding model and Gemini LLM API key with this 2.5 flash model. And for our vector store, we are using Chroma DB in our local. Okay, now this is the example, and this is the Colab notebook. All right, and this is some query, and this is also giving me those images. Now let's see the PDF that we are using in this case. Okay, so this is the PDF that we are using, this diabetes PDF, which consists several images, also some text, of course. Okay, so the first question I asked is it's that explain me diabetes with image example. Okay, now let's see. It has given me that diabetes is a chronic disease, also known as diabetes mellitus, and this text is coming from this one, from this paragraph. This is diabetes mellitus or a simple diabetes. Okay, now here is another point that you could see there is some 2 point of people with diabetes are unable to move this sugar out of bloodstream because of two reasons. Of this, pancreas does not produce enough insulin and cell do not respond normally to insulin. And with these two images of how to measure your diabetes and the organic display of how, like, some biological image of diabetes, some glucose enters the bloodstream, all this thing. Okay, and you could see those two reason is coming from this. Okay, diabetes are not able to move sugar out because of two primary reason: their pancreas does not produce insulin or do not respond normally to insulin. Okay, and if I have to show you again some example, now let's see this one. This is the image example of diabetes statistics in Louisiana state of United States. So let's ask some question about that. Okay, so yeah, so let's ask diabetes statistic Louisiana. Yeah, so here in this one I'll ask it another question that show me the statistics of diabetes across Louisiana, right? Louisiana. Okay, enter. Now it should give me that particular image. Here we go. Here are the statistics of diabetes across Louisiana. Louisiana is ranked 11th in the nation for people diagnosed with diabetes, and this is the image for sure. And if you see from where it is extracting these features or the statistics, right? So rank 11th in the nation. If I come over here, you could see Louisiana is ranked 11th. So it is extracting the information from this PDF, from this paragraph, and it is giving me with a proper bullet point. Okay, now I have made this in a simple Colab file, and if you feel that we should make a good project out of it and I should incorporate with a proper multimodal RAG application, and then just comment it out and we'll build it. Okay, now as we have understood that what we're going to do in this video, now let's see flowchart or the diagram of how this multimodal RAG will work. So here is this diagram that I've drawn. You could see from this left side where we have this red dotted box, this is where we are uploading some PDF, or my application have some knowledge base, or like my application having some knowledge base. Okay, so from knowledge base there will be two way. In one way, in one path we have to extract those text chunk, and in another part we have to extract images. So you could see we have divided into this chunk of text, and this one is, and the bottom one for images. Then we have a embedding model, and in this video we are using Cohere's embedding model. Okay, and you can have a free trial of this embedding models. Okay, you see I'm using this free trial, so you don't have to worry about having OpenAI's embedding model, which is like you have to provide your credit card to have some credits. Okay, but there is some problem. You won't be having too powerful embedding model with this, but Cohere is pretty solid. So if you really want to have a production level application, you should try its production level API. Okay, now let's come back to the diagram. So after embedding model, we'll be having vectors for text, vector for our image embeddings. Now we'll be storing them into our Chroma DB. Okay, now so this is how we come into this blue dotted box. Okay, now let's come to this right side where a user will pass a query, and this query again will be going through the same embedding model and will pass that embedded query into our Chroma DB to extract some relevant information from our vector database as per that particular embedded query. Okay, now when we'll have some relevant information of our text image, we'll pass that as a context with a proper system prompt to our LLM. Now it could be Gemini 2.5 Flash, it could be of course open GPT, any model which helps multimodal. Okay, and then this LLM will give us a proper structure output. All right, so the only difference is we need the embedding model which has this multimodal capability, and we have to extract images from the PDF. Okay, and we also need an LLM which has the power to kind of process multimodal queries. Okay, now that's being said, this is the PDF that I have used. You can use any of your like whatever PDF you want to use. Okay, now from this website of Cohere you can have your API key, and you will be having Gemini 2.5. You can have it from this aistudio.google.com link. Okay, and what more thing, we'll be using Chroma DB for our vector database, so that's something. And of course LangChain, LECL, like LangChain expression language for our basic LangChain framework. All right, so yeah, that's been said. Now let's get to the code. Okay, all right, so now I'm in my Colab notebook, and this is the diagram that we have discussed earlier, and this is our dependencies which we'll be using for our multimodal RAG system. Okay, so we are using Cohere for our text plus image embedding via that API. Then Google Generative AI, which is an Gemini native SDK. Pillow for our image processing, TQDM for progress bars, PyMuPDF for PDF parsing and image extraction, Chroma DB for which is a lightweight local vector database to store text and image embeddings, LangChain, that framework to create LLM chains, then LangChain Google Gemini, LangChain wrapper for our Gemini model. Okay, now I'll connect it. Let's see the runtime. I'll change it to T for GPU, even though it's not necessary, but still I'll connect it. And the first thing is for our setup, right? So here we need to install those dependencies, right? So code, so we need to install Cohere, Google Generative AI, Pillow, TQDM, PyMuPDF, all this. So I'll start the installation now. Wait, now for this API setup. Okay, it's done. Now I'll hide this all installation part, so show hide input. Now for the API setup, where I need to bring those API keys. Okay, so first I need to import Cohere, and from Google I'll import generative AI, let's say as for an small alias Gen AI. Okay, now simple, I need to add my API keys, so add API keys. Okay, so Cohere API keys right here, and then Gemini API keys right here. Okay, after that I simply need to authenticate these clients. Okay, so authenticate clients, here I'll use this code which will use for our embeddings. We'll call Cohere dot client v2. So client v2, and here we'll pass our API key. So our API key, which is our Cohere API keys. Okay, now same Gemini dot configure, and here I need to pass the API key and Gemini API key. Okay, alright, so I'll add these API keys over here. Alright, so this will be keys. Okay, now I'll run this cell, and that's it. Okay, now our next step is uploading our PDFs. Okay, so here I'll create a new cell where I need to have for google.colab. I'll simply import files where I'll upload those files. So let's say uploaded files. Here I'll use files, files dot this upload function, upload, and then for a PDF path, so path of this PDF, I'll use list. I'll use this uploaded files, so uploaded files. All right, and then the first one with index 0. Okay, and then I'll simply print uploaded files with passing our PDF files, PDF path. Okay, I'll enter that. We have this option. I'll choose a file from my local. Let's say I'll choose this PDF report. Okay, I'll open this. Now I have this particular PDF report. There is some error. It's saying ticked object is not callable. So list uploaded. Uploaded files. Here I need to use keys. Key is the function. Okay, now I'll choose file. I'll use this one and uploaded files. Okay, still having error. This one, right? Now it's all right. Uploaded files. Yeah, now it's all right. Okay, so I refresh this. I have these 3 because of this mistake, so I'll just delete them. Don't worry, let it go. I'll delete this and I'll delete this one. Okay, now we need to create the code. Now we need to write the code for our PDF text and image extraction. So here the first, let's say I'll import OS, and the first thing is we need to create a new folder where we'll store our extracted images, right? So let's say a new folder as image folder where I'll be storing them. So the folder path will be /content/ let's say PDF images. Okay, now I need to create this folder. So os dot make directory image folder exist. Okay, true. Okay, mean if it doesn't exist we'll create, and if it does exist we won't. Okay, enter, and you see we have this folder. Okay, now we need to extract text and images. So now we need to extract those text chunk and we need to extract our images. Okay, so here first I'll import fetch, which is a module of PyMuPDF which will help us to parse images from our PDF. Okay, now we'll initialize 2 lists of text chunk, an empty list, and image paths, an empty list where we'll store those images. Okay, now in doc variable I'll store my uploaded PDF. So fetch dot I'll open the PDF path. So I'll pass my PDF path right here. Okay, so if you see in our previous cell, we have PDF path. We have uploaded this PDF in this PDF path. Okay, now doc fetch.open PDF path. All right, now I need to iterate through our PDF to extract text and images. So for page number, so for page num in range of length of the document. Okay, I need to get the pages. So page, there's the doc of our page num. So each and every page, from each and every page we'll extract the text. So text for page dot, we'll use get text, and then if text dot strip. Okay, so we need to use this strip function to remove any white spaces. So if text dot strip, we'll add, so text underscore chunks, the empty list that we have initialized, dot append, and we'll append those text. Okay, done. Now after text, we need to work with the image. So for image, I'll take the images in this images variable. So images, where simple page dot get images. So get images, I'll pass full true to get all image. Okay, and then I need to iterate through every image. So for every image index and image in enumerate, I'll pass all the images. Okay, and here I need to get the cross reference numbers. I need to store the raw image in bytes, like the raw image. Then I had to store the images in byte format, then I had to store the extension, then the file name, then the path. Okay, so for that I have these files. I'll just use it a bit. It should be here, this one here, here. Okay, so we are taking the cross references numbers. We are taking the base image in doc.extract images. So we are extracting images as per this cross reference number. We are storing the raw image in our image byte. Then we are extracting the image extension, like it could be PNG, JPG, whatever, or SVG. Then we'll be saving those file name as page number +1. So page 1 image 1 dot PNG, JPG, whatever. Then our image path. Okay, after that we need to open this. So with open, where I'll pass my image path. So image path with WB for write, and as if, then f dot write, I'll simply pass my image bytes. All right, and then I need to append. So my image paths, simple append with image img path. Okay, after that I'll print a simple message as extracted this amount of text chunks. So my text chunk and length of image path. So image paths. Okay, so this many chunks and this many images. Okay, now control enter. You see we have extracted 17 text chunk and 7 images. Now you see this is the PDF, right? This is one of my intensive project report, and if I see how many images we have, so in this page 8 we have this one image of this flowchart, and in I think in page 13, yeah, in this page 13 we have this 6 image of classification report and confusion matrix. Okay, so if you come here and if you see page 13 image 1, which is this one, page 13 image 1, page 8 image 1, this one. Okay, so this is the utility code for resizing our images and converting this into a base 64 string image. Okay, on a like in a base 64 image string. Okay, so first, and for the resizing image we'll be using pillow. So from PIL we'll import image. Okay, and we'll also need to import our base 64. All right, and base 64 we use to encode our binary image data to a text-based format. Okay, then we'll also need to import IO, which is an in-memory byte stream, like a file in memory. Okay, all right. After that, I need to set the max pixel that I'll process. Okay, so max pixel, I'll keep it as 1568 cross 1568. You can change it as per you wish. All right, now our resize function. Okay, for that I'll use this function of resize. So def resize image, where we are taking a PIL image and we are resizing it only if it is too large. Okay, so you could see we are comparing with the origin width and origin height. If it is more than the max pixel, then we will be performing this couple of steps to making it to keep it under our resolution. So we will be calculating this scale factor, which is computed to reduce the pixel count within the limit while keeping the proportions. Okay, and all this new width, new height, and this thumbnail to kind of maintains the aspect ratio. All right, now after that we'll be having another work. So here you could see okay, so here you could see def base 64 from image. We are taking that image path in pillow image.open. We are opening those images, and if this image is not in RGB format, then we have to convert it into an RGB format. Then if it necessary, we are calling our resize image function. Then with this io.bytes io, we are creating a new in-memory byte stream to avoid saving our images into a disk. Okay, then this PIL image.save, we are saving those images to the buffer as a PNG, and this base 64 dot b64 encode, we are converting images bytes into a base 64 string and decodes it into a plain text. Okay, and then this text image PNG base 64, this prefix, and this prefix the string, so it can be directly used in any kind of HTML tag. Okay, because we have to print those images in this collapse cell format. Okay, so I'll run this cell. All right, now I need to add our Chroma DB Vectorstore. Okay, so for that I'll import Chroma DB. So Chroma DB, okay, now from Chroma DB dot config, I need to import settings. Then I need to define a Chroma client. Okay, a Chroma client where I'll call the Chroma DB dot for the persistent client, where I'll simply pass the path, which will be /content/ Chroma DB. Not in caps, let's make it so content/ okay, so we need to give the path. So path will be /content/ Chroma DB. Okay, now I need to create a collection. So in collection we'll use Chroma client dot get or create collection. Okay, like if we don't have the collection created yet, so then we'll create, otherwise we'll just simply get that. And here we need to pass the collection name, which is MultiModal embeddings. Okay, I'll run this cell and I'll refresh this. You see a Chroma DB. Okay, so now we need to store those text embeddings and image embedding to our vector store. Okay, so a new cell. The first I'll import UUID to have a particular ID for each and every session. Then from TQTM I need to import TQTM to show the progress bar. Alright, so first we'll store text embeddings. Okay, now here let's say for every iteration and chunk, for every iteration in chunk in that particular TQDM process, where we need to use this enumerate function, enumerate, where we'll pass our every text chunk that we stored in our list text chunk, and for description I'll give it storing text. Okay, with this loop, now in this race I'll store those embedding. Okay, now you could see we have this in this CO we have our Cohere embedding, right? So what we'll do, we'll call that CO. So CO dot, will simply use embed, and here we need to pass those model parameters. So model will be our, we can use the model as, let's say, embed hyphen v4 dot 0. Okay, so this will be our model name, and input type, here we'll use our search document, and for our embedding types, for those embedding types, here we'll collect it as float, because every vector embedding kind of shows in a float format. Okay, now in texts I'll store the in chunk. Okay, so in this text I have my embeddings. Now in emb trace dot embeddings, I'll be taking the first iteration, so float O. Alright, so the first index of those embedding vectors. Then I need to add this embeddings into our collection, so collection dot add, and here I'll pass with the particular ID. So ID would be, let's say, text of UUID dot UUID 4. Alright, and then we need to pass our documents with chunk, and then we need to pass embeddings with emb, so emb, and finally we need to pass the metadata, so metadatas, which would be in the format of first we need to provide the type, so type with text. Okay, alright, so after that we need to create our image embedding, so image embeddings. Okay, Now it will be pretty much similar. So let me just copy this one and I'll modify this. Okay. Now for I and chunk, but there is no I in this our image. So here we'll use simple our img path. So for img path in those tqdm, and here we need to provide in place of text chunk and enumerate, we can provide, wait a minute, we can simply provide our image path. Okay, so image paths. So for image, for img path, in every image path with description of storing images. Okay, now after that we need to get our base 64 image string. Okay, so base 64 img, where I'll use base 64 from image, and I'll pass my img string, img path, and this function is this one, base 64 from image, and we are converting those images into a base 64 string. And after that I have to prepare the API input. So in this API input I provide first the content, and the content will be in the format of not here, in the format of type, and the type is image. So image, and every image will be in the form of base 64, right? So base 64 image, this one. Okay, now this will be our API input for our Cohere embedding. Now we have this res co.embed, model name would be same, embed v4.o, input type search document, embedding types float, inputs here in place of this chunk will, in place of this text it will be inputs, and here we'll provide our API input. Okay, now emb will be res.embeddings float 0. Okay, collection.add IDs, it will be image, not text, image, uuid, embedding emb, this documents will be in the format of img path. Okay, so img path, and metadata, this will be image. All right, done. Now I'll run this cell saying problem in float, embedding types float, invalid syntax. All right, there will be a comma, right? All right, embedding types, here is should be a comma. Okay, again got an unexpected keyword as input type. All right, so there is some error. Input type to be input. Okay, so you could see storing text for every iteration. Some error, got an unexpected keyword as input type. Sorry, I have copied it now. Okay, now right, so storing text, storing our images, and you see, all right, so we have 17 iteration and storing images, everything. Now in this Chroma DB we have stored every embedding models, every our embedding vectors. Okay, so now for prompt formatting via LangChain LCEL. Okay, so here we need to provide a proper prompt template, and we'll be creating the chain so that we get a proper structure output as per our query. Okay, So first we need to import a couple of libraries. So we are importing this chat Google Generative AI, string output parser, chat prompt template, message placeholder, human message runnable pass-through, and to initialize our Gemini LLM, this chat Google Generative AI, which is the same one, but I have this written this for a individually. Okay. Now we need to define the LLM. Okay. So LLM here we'll call our chat Google Generative AI. All right. Now I need to pass the model that I am using. So which would be Gemini 2.5 flash, and then for the temperature I'll make it 0.3, like not too much. Okay, then I think this should enough, but still just pass the API key. So Google API key, so Google API key, where I'll pass my Gemini API key. Okay, done. Now after that, here I need to define the structured prompt template. Okay, so simple prompt template. Here I'll call this chat prompt template. Okay, dot from messages. So from messages, and here I'll provide my system message. So second bracket, third bracket. Now here again in the first bracket, I first need to provide the system message. So system, which would be, let's say you are a helpful AI assistant that answers questions using only the provided context, right? And for the human message, human, it will be the comma here, answer the following question, and okay, the question is this one question, and then to add the context, so /n context would be this one. Okay, context. All right, after structuring this prompt template, we need to define LCEL chain with prompt template. Okay, so I'll create a simple response chain. So response chain, where I'll call the runnable pass-through. So runnable pass-through, and not the warning one, runnable pass-through, and here after that I'll add the chain. So with a lambda function where we'll work with the question and the context. Okay, so with a lambda function with our inputs storing in this particular question. So question would be inputs of question, and for the context is here inputs of context. Okay, now again a chain where we'll pass our LLM. So our LLM, again another chain where we'll pass our string output parser, just space. Here it will be a function. That's it. Okay, now this one is ready. I'll run this cell. It's done. Alright, so for in this response generation via Gemini LLM cell, we'll create a function as def of search and answer. So here we'll take the question from user, we'll embed that, we'll retrieve some relevant information, our image, then we'll pass the answer. Okay, so here we'll pass our question, also the top relevant information, let's say top k. We'll be taking it as of now, we are taking two relevant information, like two relevant chunk. The first thing we need to do, we need to do this query embedding. So query embedding. Okay, and to do that I'll simply use this one. I'll copy this one and I'll pass it right over here. Okay, so res co.embed model will be this one. Input type search document. Input type would be not document, it would be search query. Search query, embedding type float, text would be my question. Now emb, it will be query embedding. So query underscore emb res dot, change this res to query res, qres. Now make it qres dot embedding float 0. Okay, all right. After that we need to pass this query embedding to our Chroma DB. So pass to Chroma DB. How will do that? Simple, taking our results here, we'll pass our collection dot, I'll use that query. Here we'll pass our query embedding. So query embeddings, here I'm passing my query emb. Okay, and I also need to pass the number of results that I want to retrieve from my Chroma DB. So in result, and I'll simply pass top k 2. Okay, now I'll retrieve the information based on this. Now I need to store the like the information we'll be having, I need to store them. So top text into a empty list. So top text and images into an empty list. So empty list. This will be comma. All right. So now the relevant text and relevant image that I'll be having from Chroma DB, that is been stored in these results, I need to separate my text and image, and I need to add them into this top text list and in this top image list. Okay, so for that what I'll do, for doc and metadata. So meta in, let's say we're zipping this results, so whatever we'll be having in this results, so results dot documents with the fast index and results of metadata, because in metadata we'll be storing our images. Okay, now 0. Okay, now if our metadata type is text, we need to embed, so we need to append in the top text list that particular doc. Okay, and let's say elif, not else, elif, if my meta, so meta of type is image, then in this top images, right? In these top images, I'll simply append that given doc. Okay, there we go. Okay, now after separately adding in this list, we need to make sure that we are only taking those up to those relevant information. Like we might have 10 amount of chunk, but we can only take as context only 2 chunk, right? So we need to trim them. So for that, in our top texts, in this top texts, sorry, it will be under this function now. So the top text, I need to trim this, so we can top text up to top k. Okay, not this one, I need to use this one, up to top k. Same for this top images, I need to use top images up to this top k relevant info. Sorry, top k relevant info. Okay, after separating and taking only the relevant information, we need to prepare the context. Okay, so context, here I'll take, let's say, some new line, then I'll join. So I'll join with, here I'll have my top text, so top text, then I'll add with let's say my images. So here I'll use my image, which is this img image, and I'll use this for in this loop for img in my top images loop. Okay, I think now it makes sense. So for img and top images, I'm only taking these images. Okay, now we simply need to call our final LangChain. So response text, here I'll call my response chain dot invoke, where I'll simply pass the question, which would be this question, and for context I'll pass this context. Okay, it will be under this second bracket. So second bracket. Okay, now simply as this is a function, so this function will return this response text and top imgs, top images. Okay, I'll run this cell. Okay, so now for this final output, right? So as we need to display images, so we need to have our ipython dot display, need to import display. Okay, then we need to have our question, which will be adding right here. Then we need to call our search text function. So first answer text and those result images. Okay, now we'll call our search text function, search and answer. We'll pass our question, and then we'll simply print answer, and here is print answer the text. Then for img in result images, display. I need to provide my image dot open img. Okay, now if you see here, we have this multiple 6 images. Okay, so let's say this is the logistic regression confusion matrix, and this one is for random forest. So I'll ask a simple question that explain me the logistic regression confusion matrix. Let's see. Okay, so you could see confusion matrix for logistic regression on the validation data. Based on the provided context, there are images that appear to be a confusion matrix. However, there is no accompanying text or explanation within the context to describe or explain the logistic regression confusion matrix. All right, so the problem we have with our provided context. Okay, so we have another one. This one's for this both are same, right? All right. Now what we'll do, we'll just copy this. We'll paste it over here. Now this time we'll use, let's say, explain me the sentiment analysis system flowchart. All right, I'll run this cell, and you see this particular image for sentiment analysis. This image we got. Now let's see the provided context. Based on the provided context, there is no explanation of a sentiment analysis. So there is the problem we are having because our prompt, our context is not so powerful. That's why in this case. Okay, so let's try something else, and let's see. And here we go, and here we'll see that describe me the classification report for random forest test on validation data. Okay, I'll run this cell. Let's see, and you see confusion matrix for random forest. Confusion matrix for random forest. Provided context defines a classification report as providing precision recall F1 score for each individual sentiment class, offering a detailed breakdown. However, the context does not provide the actual classification report values. So I think the embedding model that we are using for Cohere is not able to extract the values, but I feel that's fine because you could see the images are quite blur, so it will be tough for them to extract. Okay, now let's try with some simple text. The text would be, let's say, simple text as what is logistic regression, random forest, and gradient boosting. So explain gradient boosting. Classifier. The gradient boosting classifier is a powerful ensemble method that builds models sequentially. All those things. We have this one. Okay, that model that builds the model sequentially. Each new model attempts to correct the errors. All right. So that was for this video, this multimodal RAG where is extracting images with some context. Of course, the problem we have in our embedding model power and the context that we have given to it. Okay, so yeah, this was for this video, and thanks for watching.